Hello and welcome to this series of product demonstration videos for Visualfiles. In this session, I will be talking about a new option providing full encryption of your Visualfiles database. So why is encryption fast becoming the must-have feature for your database? Well, over the last few years, we have seen a number of high-profile data losses in the media. For those organisations, the fallout has been significant, leading to reputational brand damage, immediate loss of existing customers, slowdown attracting new customers, substantial compensation to affected parties, unplanned offers, price reductions, and hefty regulatory fines. Early next year sees the introduction of GDPR, the new EU data regulations. Whilst the regulation brings many requirements around the retention and use of data, it also covers measures to protect data from falling into the wrong hands. Specifically, the right to know when one's data has been hacked. Organisations must notify the authority of data breaches that put individuals at risk and communicate to the data subject all high-risk breaches as soon as possible so they can take appropriate action. Data protection by design. Data protection safeguards should be built into products and services from the earliest stages of development. Stronger enforcement of the rules. Data protection authorities will be able to fine companies who do not comply with EU rules up to 4% of their global annual turnover. So implementing safeguards around the retention and use of your data isn't enough. The physical data must be protected from accidental loss or theft. Transparent database encryption is abbreviated to TDE. It is also known as security at rest, referring to data held in persistent storage such as a database. The term transparent refers to it being completely invisible to users of the Visualfiles application. All components in the Visualfiles suite function without any impact. TDE provides encryption inside the actual database files rather than the file system. The advantage being, if you copy the database to an offline location, such as a different server or a USB archive device, the encryption remains in place. The TDE implementation for Visualfiles makes use of industry standard ciphers such as AES-128 and AES-256 and operates using secure key stores. Data in the database can only be accessed when the relevant key is securely in place. The minimum requirement for Visualfiles TDE is release v3.4. So let's take a look at it in action. Before implementing TDE, let's take a quick look at one of the database files. Navigate to the directory containing the database. Highlight one of the data files and open using a text editor. As you scroll through the data, you can see that much of the information is stored in plain text. It is this information that TDE will encrypt. The first step is to ensure all OpenEdge services have been stopped. On your database server, open Windows Service Administration. Highlight the OpenEdge admin service, right-click and open Properties. Ensure startup type is set to manual and press OK. Go ahead and reboot the machine. Next, install a copy of the OpenEdge TDE product onto your database server. Once that is done, we can generate a set of installation files specific to your Visualfiles database. Click the icon to launch the utility. This ships a standard with releases of Visualfiles from 3.4 onwards. Enter the directory that contains the database and select the required cipher from the drop-down list. Strength 128 provides the simplest level of encryption with minimal effect on performance, whilst 256 gives the highest level of encryption but introduces a marginal performance overhead. In reality, it is very unlikely users will notice any performance impact, even with the highest levels of encryption. Leave all tick box options set and press Generate Scripts. 5 bat files will be created in your database directory. With the admin service stopped, open a proenv command shell and switch to the database directory. We will truncate the database BI file. Next, we launch the setup file that enables encryption inside our database. This makes the database capable of being encrypted. The actual encryption of data will take place shortly. Type enable encryption.bat and press return. Follow the instructions carefully. Enter an administrator's password. This must contain at least one number, one uppercase letter, and one punctuation character. You need to retype the password. Next, enter a user password. This must also contain at least one number, one uppercase letter, and one punctuation character. It cannot be the same as the administrator's password. Finally, you need to retype the user password. The database is now in a state that will allow encryption. Staying with your proenv command prompt, we need to apply all the encryption settings to the various tables and indexes. Type apply encryption.bat followed by your administrator's password. At this point, we can restart the OpenEdge services and allow users to log in and continue using Visualfiles. All data at this time remains in the database as clear text, but any new data entered or changes made to existing data will be written to the database in encrypted form. Using Windows services, we reset the startup for the OpenEdge service to automatic. And then press Start. The final stage in the installation and setup process is to perform a bulk encryption of all existing data. Using a proenv shell, make sure you are located in your database directory. Enter update encryption.bat followed by your administrator's password. This can be processor intensive, so you may consider deferring it as an out-of-hours task. Let's take another look at our database directory. The encryption process has created a new file called soldb.ks. This is the key store file and is critical to the ongoing use of your database. In order to gain access to your database, this file must be present in the data directory. Without it, you cannot connect and access data. Keep it very safe and secure. From a data theft perspective, this file must be separated from the other database files whenever it is copied, archived or backed up. Should the database fall into the wrong hands, it cannot be accessed without the key store file. Let's have a quick reminder of how our database looked before encryption. Notice how data is stored in plain text and is human readable. If we look at the same data file after encryption, we can see that the data is now unreadable. At this point, the installation and setup is complete. You are good to go. You should now start to consider ongoing routine maintenance such as changing passwords and rekeying the data to change the algorithms used to encrypt the data. Let's take a look at how to re-encrypt the data using a new key. Open the OpenEdge administration utility and connect your database. You will need to use the Options button and tick the passphrase box. After pressing OK, you will need to enter the administrator's password. From the window menu bar, select Admin, followed by Security, Encryption Policies and Generate Encryption Keys. Press the Select Some button, followed by OK and OK again. Press the Commit button to apply the change. We can, at any time, take a look at the status of encryption. From the window menu bar, select Admin, followed by Security, Encryption Policies, and then Encryption Policy History. We can see that we have a current and a previous policy. All existing data is held in the previous policy, encrypted using the original key. Any new data added or existing data updated will be encrypted using the new key. Once all data has been updated using that new key, the previous policy will disappear. We can force all data to re-encrypt using the new key from the current policy and remove the previous policy by performing the bulk encryption again. TDE has two operating modes. Auto Start. This mode requires that the key file exists in the same directory as the other database files. If it exists, Visualfiles can connect to the database and decrypt the data. If the file is not present, access to the encrypted data is prohibited. This mode assumes that the application administrators have strict procedures in place to manage the key file, ensuring that it exists only in the directory containing the database and access to that folder, and therefore the key file, is restricted. It also assumes that all backup copies are managed, saved and transported without the key file. Like Auto Start, manual mode requires that the key file is inside the folder with the database. Manual mode adds an additional layer of protection by demanding that a passphrase be entered whenever the database is accessed in single user mode or when serving the database for multi-user access. This means that even if the key file along with the database files falls into third-party hands, the data cannot be accessed without the password. But this mode demands considerably more complex administration processes for serving the database, and for this reason Auto Start is the recommended approach. When considering a TDE project, it is essential to fully read and understand the detailed documentation. A clear knowledge is required of the encryption process, the significance of the key store, rotation of keys, ciphers, passphrases, and critically the policies for backup and restricting access to directories containing the production database. Thank you for watching. Further information can be found at lexisnexus-es.co.uk.